We are going to do a short video today talking about physical and chemical properties and physical and chemical changes. So, starting with what a physical or chemical property is, a physical property is usually a feature of a substance that is shown by the substance without having to do anything extra like a reaction. So, we're talking about the natural properties that a substance has. So, the odor of a substance, the taste of a substance's boiling point, the density of the substance. These are all features or properties that are displayed by a material or substance without that material having to go through any chemical change. For example, if I have something like maybe gasoline, just looking at the substance, gasoline has a distinct odor, right? And some people have tasted gasoline. It does have a distinct taste, and of course, it will have its natural boiling point and its natural density. These are all things that gasoline has on its own without having to go through any reactions or any burning. Then, if we bring it to the chemical properties are features a substance will only display when it is going through a chemical reaction or a chemical change. So, these are things that aren't naturally showing up with the substance. The substance has to go through some type of chemical change before we can identify these chemical properties. So, the smell of gasoline, the odor of gasoline, that is a physical change. But if I want to burn gasoline and I want to make gasoline flammable, then the flammability of gasoline is more of a chemical property because it's not something we will see on its own. It's something that would need to show up after a chemical change or chemical reaction, in this case burning, happens. The corrosiveness of a substance, in addition, is a chemical property because we don't see it on its own. Like it doesn't naturally show up with the substance. It does need to have the substance maybe touch something else and go through a reaction to decompose or corrode that substance. And then the toxicity and acidity. These are all things that we don't naturally see in the substance. The substance needs to go through some type of reaction or it needs to get in contact with another substance before we can see these types of features. And so a physical change is a change that occurs when the physical property is changing, for example. Here is one example that I have. If you're boiling water, so this is talking about boiling points, which is a physical property. The substance is going from water, which is a liquid, and then it's going to water vapor, which is a gas. But keep in mind that the chemical composition of the substance is not changing. It's still H2O in water form and H2O in vapor form. The chemical composition of this substance is not changing. It's still water and water in the future, even after boiling. Even when you melt something, if I melt ice or I melt ice cream, the substance I'm dealing with, the chemical composition of that substance does not change. It's still ice cream, it's just melted ice cream. It's still water, it's still H2O, but it's going from frozen water, ice, to liquid water, which is just water. And even if I shred paper, for example, shredding the paper does not change the fact or negate the fact that we are dealing with paper. It was just paper in a page and then it becomes shredded paper. But the material of the paper does not change chemically. And if I chop a tomato, it was still a tomato before I chopped it, and even after I chop the tomato, it is still gonna be a tomato. So the substance I'm dealing with does not go through any change. So there's no change in the composition of a substance when it's physical. Some of these physical changes are reversible. For example, if I boil water, I just have to cool the water vapor and then I'm going to get my liquid water back. Or if I melt ice, if I want to get that ice back, I just have to go ahead and put that water that melted in the fridge, or sorry, in the freezer, and it will freeze back and become ice. So some of the physical changes we deal with are reversible, Actually, a lot of them are reversible. There are some that are not really reversible. Like if you shred paper, it's not easy for you to get that full paper back. Or if you chop a tomato, you can't just, you know, snap your fingers and get the full formed tomato back. But some of these physical changes are reversible. A lot of them are actually reversible. And then you have your chemical changes. Chemical changes, this in the chemical change, the substance you are dealing with undergoes a chemical change due to a chemical reaction. So what you had, the material or the chemical structure you had before the change is not the same as the chemical structure you have after the change. Let us look at this situation of rusting. So I have an iron nail, and this nail is undergoing rusting. On a surface level, you see that it adopts this brownish color, this brownish orangish rust color. So that should hint at the fact that the substance you're dealing with is going through some type of chemical reaction. And truly, what is happening in rusting is an oxidation reaction, which is basically a reaction where a substance is reacting with oxygen. The iron nail before was just plain iron atoms, Fe. But then the rusting process led to a change in the chemical property. So there was a corrosion, which is a chemical property. A chemical change was happening. And basically, the iron was reacting with oxygen in the air to produce iron oxide, which is a completely different chemical structure. So your iron can go from iron, just plain iron, to iron oxide, a completely different chemical structure, which we see as rust. And even in the case of combustion, combustion is a chemical reaction where you have hydrocarbons, so substances in the wood are reacting to produce new substances, which are carbon dioxide, which goes into the air, and water. The fire also produces a brand new substance. So it's no longer wood, it will become ash. So there is a change in the material. And so we see this as a chemical change because the material's composition from before the chemical change is not the same as the material's composition after the chemical change. And of course, we talked about rusting, which is a corrosion. Combustion is talking about flammability. Rotting is a biological process that is irreversible. So there is a decomposition happening in the rotting process. The complex sugars you had in this apple break down due to enzyme action. So the enzymes basically go in and they break down the composition and the sugars and the fibers in the apple, and it decomposes that apple or whatever fruit down until the fruit is barely recognizable. This is the chemical change because enzymes are acting to break down all these different features of the apple. And then also digestion, which happens in our body. We eat the food and the food breaks down, chemically, the complex sugar, complex proteins, all those things, even the fats break down and emulsify until they become minute substances that we can absorb into our body so that we can maintain life. Most of the chemical changes we deal with are irreversible. So that means that we can't go back to the material we had before. This iron oxide doesn't just spontaneously go back to iron. This apple that rotted will never go back to being a whole apple. The ash, that's the production that is produced from the combustion of wood, doesn't just spontaneously become wood again. These things are usually irreversible. Some chemical changes can be reversible, but majority are irreversible.